السلام عليكم.
السلام عليكم.
وعليكم السلام ورحمة الله وبركاته.
كيف الحال؟
الحمد لله دكتور، كيف الحال؟ زي حضرتك؟ زي الصحة؟
الله يسلمكم. الحمد لله، الله يبارك فيكم. كل عام وانتم بخير.
كل عام وحضرتك بصحة وسلامة يا رب. الله يحفظك يا رب.
الله يسلمكم يعني.
اقلل اللود على السيشن. يعني عندنا 4-5 كمبيوترات. دكتور احمد لو سمحت اصور له تسكر اللي تقلل اللود على النتورك، ما نحتاج احنا
بس شغال مع الصوت.
السلام عليكم.
Alaikum assalam, Mr. Muhammad. How are you?
السلام.
وعليكم السلام ورحمة الله.
عليكم السلام ورحمة الله.
وهذا سويات كده غلط، سويات كده طاولة.
Please open the mic.
بسم الله الرحمن الرحيم، والصلاة والسلام على رسولنا الكريم سيدنا محمد بن عبد الله الأمين وعلى آله وصحبه أجمعين. السلام عليكم ورحمة الله. Good morning everyone. Under the patronage of respected Prof. Dr. Ahmed bin Khalfan al-Rawahi, the Chancellor of the University of Nizwa, the College of Engineering and Architecture organizes the 11th National Symposium on Engineering Final Year Projects. On this occasion, we would like to welcome all participants and wishing you a nice day and pleasant experience. According to the symposium schedule, we would like, according to the symposium time schedule, we welcome, we will start the ayat from Holy Quran recited by Engineer Khalid Al-Hosni from the Chemical and Petrochemical Engineering Department. Mr. Khalid, the base is yours.
أعوذ بالله Start. أعوذ بالله من الشيطان الرجيم ويسألونك عن ذي القرنين قل سأتلو عليكم منه ذكرا إنا مكنا له في الأرض وآتيناه من كل شيء سببا فأتبع سببا حتى إذا بلغ مغرب الشمس وجدها تغرب في عين حمئة ووجد عندها قوما قلنا يا ذا القرنين إما أن تعذب وإما أن تتخذ فيهم حسنا قال أما من ظلم فسوف نعذبه ثم يرد إلى ربه فيعذبه عذابا نكرا وأما من آمن وعمل صالحا فله جزاء الحسنى وسنقول له من أمرنا يسرا ثم أتبع سببا حتى إذا بلغ مطلع الشمس وجدها تطلع على قوم لم نجعل لهم من دونها سترا كذلك وقد أحطنا بما لديه خبرا ثم أتبع سببا حتى إذا بلغ بين السدين وجد من دونهما قوما لا يكادون يفقهون قولا قالوا يا ذا القرنين إن يأجوج ومأجوج مفسدون في الأرض فهل نجعل لك خرجا على أن تجعل بيننا وبينهم سدا قال ما مكني فيه ربي خير فأعينوني بقوة أجعل بينكم وبينهم ردما آتوني زبر الحديد حتى إذا ساوى بين الصدفين قال انفخوا حتى إذا جعله نارا قال آتوني أفرغ عليه قطرا فما استطاعوا أن يظهروه وما استطاعوا له نقبا قال هذا رحمة من ربي فإذا جاء وعد ربي جعله دكا زكا وكان وعد ربي حقا صدق الله العظيم.
صدق الله العظيم. Thank you, Engineer Khalid. Now it is the time for the welcome speech by Prof. Hussein Al Abdul Qadir, the Dean of College of Engineering and Architecture. The screen is yours, Prof. Hussein.
بسم الله الرحمن الرحيم والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. الأستاذ الدكتور أحمد بن خلفان الرواحي الموقر رئيس الجامعة وراعي الحفل. ضيفنا المحترم الفاضل الدكتور عبد العزيز بن راشد الهاشمي المتحدث الرئيسي في الملتقى. الأساتذة الأفاضل نواب ومساعدي رئيس الجامعة، الأساتذة الأفاضل عمداء الكليات، الأساتذة الأفاضل أعضاء الهيئة التدريسية، الأفاضل المشاركين في الملتقى الوطني 11 لمشاريع التخرج الهندسية، أعزائي الطلبة والطالبات، أعزائي المشاركين، السلام عليكم ورحمة الله وبركاته. في رحاب جامعة نزوة ينعقد الملتقى الوطني 11 لمشاريع التخرج الهندسية في هذا اليوم 10/5/2022 وبشكل افتراضي وعن بعد، وتحت عنوان تطبيقات نحو تطبيقات تقنية متقدمة. وقد استمرت جامعة نزوة مشكورة على عقد هذا الملتقى وبنسخته 11 وبدعم ورعاية من رئيس الجامعة الموقر الأستاذ الدكتور أحمد بن خلفان الرواحي، وامتدادا لملتقيات وطنية سابقة منذ عام 2011 حيث أثبتت نجاحها والحمد لله من خلال عدد البحوث المتقدمة للملتقى وكذلك نوعية البحوث المقبولة والمعروضة في هذه الملتقيات. يعتبر هذا الملتقى الوطني منصة ومنبرا للطلبة من كافة التخصصات الهندسية ومن مختلف الجامعات والكليات الهندسية في سلطنة عمان ومن خارج السلطنة لأجل اللقاء السنوي والمشاركة في أحدث البحوث والابتكارات في مجالات الهندسة والتكنولوجيا. ولقد تم اعتماد موضوع الملتقى نحو تطبيقات تقنية متقدمة، وذلك لتعزيز روح الابتكار لدى طلبتنا الأعزاء ومدى تأثير ذلك على التطور التكنولوجي المصاحب لهذه الثورة الصناعية والتكنولوجية المستمرة وبلا حدود. وتتمثل الأهداف الرئيسية للملتقى في نشر وتبادل المعرفة بين الطلبة والأساتذة المشرفين عليهم في مجال البحوث التطبيقية الهندسية والمعمارية ومدى إمكانية تطبيقها صناعيا، وكذلك اطلاع الطلبة على ثقافة البحث العلمي والأفكار الجديدة وكيفية كتابة البحوث. وسيتم عرض البحوث المستخلصة من مشاريع التخرج الهندسية من مختلف الكليات والجامعات من خلال 10 جلسات عرض ومناقشة عن بعد، حيث تهدف إلى تشجيع روح التعاون والمشاركة الفاعلة في المجال الهندسي والعمل كفريق يملك روح الإبداع والابتكار والقدرة على اقتراح الحلول المناسبة للمسائل الهندسية المطروحة. وفيما يخص ملتقانا هذا 11 لمشاريع التخرج الهندسية، فقد تم قبول 63 بحثا وورقة عمل من مجموع 66 بحثا، والحقيقة ذلك يدل على مدى النوعية العالية للبحوث المتقدمة لهذا الملتقى. وقد قدمت هذه البحوث من 12 جامعة وكلية هندسية في سلطنة عمان، وهي جامعة السلطان قابوس، جامعة نزوة، الجامعة الوطنية للعلوم والتكنولوجيا، الجامعة التقنية والعلوم التطبيقية بفروعها في نزوة وإبرة والمصنعة وصحار وشناص. وكذلك جامعة البريمي وكلية الشرق الأوسط وجامعة صحار وكلية صور الجامعية، إضافة إلى مشاركة من خارج سلطنة عمان من جامعة الموصل من العراق، أي ما مجموعه 13 جامعة وكلية هندسية قد شاركت في هذا الملتقى. وهذا والحمد لله أحسن دليل على نجاح هذا الملتقى الوطني، والذي يتم من خلاله تبادل الخبرات والأفكار ونتائج البحوث التطبيقية حول مختلف الجوانب الهندسية، مما يؤدي إلى تعزيز التواصل بين الطلبة وباحثين ذوي خبرة بحثية وعملية في المجالات الهندسية المختلفة، من أجل الاطلاع على الأطر البحثية والمنهجيات وإدارة التطبيق العملي داخل هذه المؤسسات والجامعات المشاركة في هذا الملتقى. وأود أن أشير هنا إلى النوعية العالية التي اتسمت بها البحوث المقبولة في هذا الملتقى الوطني 11، والتي حرص فيها القائمون على الملتقى والمقيمين أن تكون البحوث المقبولة ذات نوعية وجودة عالية تتلائم مع مستوى وسمعة هذا الملتقى، مما يحقق الأهداف المرجوة منه، وذلك صعودا بأبنائنا الطلبة والطالبات إلى المستوى العلمي والبحثي المطلوب. كما أود أن أبين لكم بأنه سيتم نشر بحوث مختارة من هذا الملتقى في مجلة الهندسة والتكنولوجيا، والتي تصدر في الجامعة التكنولوجية في بغداد العراق. كما أود أن أعرب عن خالص امتناني وشكري للدكتور عبد العزيز بن راشد الهاشمي من تنمية نفط عمان على مساهمته بتقديم محاضرة قيمة بعنوان المهارات المتقدمة والمطلوبة في الصناعة. والشكر موصول للأستاذ الدكتور أحمد بن خلفان الرواحي الموقر رئيس الجامعة لتشجيعه ودعمه المتواصل لمثل هذه الفعاليات الهندسية. والشكر الجزيل للدكتور وميض عبد المجيد رئيس اللجنة التحضيرية للملتقى وكافة أعضاء اللجنة التحضيرية واللجان التنظيمية الداعمة لإكمال هذا الملتقى على الوجه المطلوب. كما أشكر جميع المشاركين من طلبة وأساتذة، وأتمنى لهم مناقشات مثمرة، وذلك تحقيقا للأهداف المرجوة من هذا الملتقى. وشكرا جزيلا.
Thank you, Prof. Hussein. Now it is our pleasure to share with you a short film overviewing the development of Nizwa University since its establishment.
أبنائي، كنا بالأمس حافظين سور في القرآن الكريم، من منكم حفظ سور بالأمس؟ نعم.
نحن جزء من هذه الأرض، روحها وعلمها، فنها وموهبتها. كل صباح تشرق الشمس على هذه الأرض العظيمة، تتكشف ملامح نهضتها وتبرز مشاريعها النابضة بالحياة، والأكثر أنها تعكس أفكاراً آمنت ببناء إنسانها العماني وسخرت السبل لتنمية قدراته.
من الانتقال بأمان إلى مستوى طموحاتكم وآمالكم في شتى المجالات سيكون عنوان المرحلة القادمة بإذن الله.
جامعتنا صرح يسهم في كل مجال تنموي عبر تخصصاتها المختلفة، ومنبر يصدح منه صوت العلم معتلياً أرجاءها، مؤكداً على القيمة الثقافية التي تضيفها برؤية متزامنة مع رؤية أرضها وطموح شعبها. ومن جانبنا فنحن نسخر كل إمكانياتنا في بناء الإنسان بتعليمه وتأسيسه ليكون مستعداً للمشاركة في بناء وطنه عبر المراكز البحثية والخدمية وخدمة المجتمع. ونهيئه للانطلاق بأفكاره الصاعدة عبر حاضنات الأعمال والريادة. العلم يداوي مرض، يحل مشكلة، يبني عمارة، يسهم في ازدهار الأمم. ففي مشاركة المعارف تتأكد نظريات وتستبعد أخرى، ومنه تطورت العلوم واستحدثت تخصصات جديدة، ففتحنا لطلابنا الأبواب لينطلقوا في دراستها.
توفر جامعة نزوى برامج أكاديمية متنوعة لكافة الدرجات الأكاديمية، تندرج تحت 4 كليات، تدرس من خلالها تخصصات واسعة ودرجات علمية متنوعة، منها 42 برنامجاً في درجة البكالوريوس، 27 برنامجاً في درجة الدبلوم، برنامجين في درجة الدبلوم العالي، و28 برنامجاً لدرجة الماجستير. كما استحدثت الجامعة درجة الدكتوراه في علوم الكيمياء. يبلغ عدد الطلبة المنتظمون على مقاعد الدراسة 6836 طالباً وطالبة، منهم 434 طالباً وطالبة في درجة الماجستير. كما بلغ عدد الخريجون من الجامعة منذ نشأتها أكثر من 16,000 خريجاً وخريجة من مختلف الدرجات العلمية انطلقوا إلى سوق العمل.
ما الذي دفع الإنسان للتقدم؟ إنه الفضول. العلم يبدأ بطرح الأسئلة ويتبعه الفضول نحو معرفة أجوبتها. بالأبحاث العلمية نجسد السؤال تحت مجهر المراقبة، نحلل كل المعطيات والنتائج ونخرج بأجوبة محتملة تقودنا لتساؤلات أعمق. تنطلق كل العلوم من أبجدية الإنسان، لغته الأم وتاريخه وتجربة حضارته وأمهات الكتب في رفوف مكتبته، إلى عوالم أوسع بكثير من العلوم والتخصصات المختلفة.
يعتبر البحث العلمي والابتكار العصب الرئيسي في الجامعة، وهو بدوره يحقق الأهداف الاستراتيجية البحثية ورؤية وتطلعات الجامعة في هذا القطاع بمراكزه المختلفة، وهو اتحاد من العلماء المتميزين بخلفيات علمية متعددة أسهم في إبراز العديد من المنشورات البحثية الذي فاق 1000 منشور في مجلات علمية مرموقة، شمل ذلك براءات الاختراع والأوراق الأصلية وأصول الكتب ووقائع المؤتمرات. ومع تعاون الجامعة مع أكثر من 50 جهة بحثية خارجية يرتقى مستوى تبادل الخبرات والبحث العلمي المشترك بمستوى الأبحاث والابتكارات.
الإنسان هو استثمارنا الأكبر بالعلم، تتغذى مداركه، نمنحه الأدوات ونزوده بالمصادر، ونخلق له بيئة يعبر فيها عن أفكاره. ننطلق إلى ما هو أبعد خارج حدود الجامعة، إلى المجتمع من حولنا عبر برامج تدعم التعليم وبرامج تنير الأذهان إلى آفاق معرفية جديدة.
خدمة المجتمع هو أحد الأركان الأساسية للجامعة التي تقوم بالمساهمة في نمائه ببرامج مختلفة مستعينة بمنظومة الجامعة المتكاملة. وقد أنشأت الجامعة مركز خدمة المجتمع لتقديم البرامج التي وصلت إلى 582 مشروعا للإنماء المعرفي، و524 مشروعا للعون التنموي، و296 مشروعا للتفاعل المجتمعي. تخصص الجامعة ما نسبته 1% من الإيرادات السنوية للجامعة، حيث بلغت التكلفة منذ إنشاء الجامعة حتى الآن ما يزيد من 2,000,000 ريال عماني. أنشأت الجامعة صندوق معين حيث يهدف إلى تقديم العون والمساعدة المادية والمعنوية لطلاب الجامعة، ليتمكن الطالب من التغلب على التحديات المالية التي قد تعترض مسار حياته الأكاديمية. خدم الصندوق منذ إنشائه حتى الآن أكثر من 56,000 طالب وطالبة بتكلفة مالية قدرها 37 مليون ريال عماني.
خطوة تليها خطوة، يرتقي الطالب هنا بالتجارب والخبرات ليطبق ما تعلمه من خلال برامج التدريب والتوظيف في بيئة تستثمر فيها الأبحاث لتعود بعد نضجها بأفكار تجارية خلاقة.
جسد مركز ريادة الأعمال رؤية الجامعة في بناء الإنسان وإطلاق طاقاته، ومن خلال 3 سنوات مضت بلغ عدد المستفيدين من خدمات المركز حوالي 11,000 مستفيد. واستثمرنا في مشروع حاضنات الأعمال، أحد المشاريع المهمة وبوابة لولادة مشاريع وطنية فاعلة في الاقتصاد الوطني تعزز رؤية عمان 2040. كما مثل المركز السلطنة في مرصد ريادة الأعمال العالمي، وقد اهتم المركز أيضا ببناء شراكات فاعلة مع الداعمين لمنظومة ريادة الأعمال، بما يمكننا من تحقيق الأهداف والتطلعات التي قمنا من أجلها. وأطلقنا العديد من المبادرات المجتمعية، وشاركنا ونظمنا العديد من المسابقات والفعاليات المحلية والدولية.
منذ سنوات عديدة وضعنا لبنة هذه الجامعة على مبدأ واضح: أن يجد الإنسان هنا ما يلهمه لتنمية وطنه ومجتمعه، إرثه وحضارته وثقافته، ويرسم مستقبله لينسجم بثقة مع رؤية عمان 2040. الإنسان تبدأ منه كل الحكاية وتعود إليه كل تفاصيلها. اليوم نتطلع بشغف استكمال بناء حرم جامعة نزوى الجديد، مدينة ملهمة بعلاقتها وسمو مكانتها العلمية، ليكون منارة جديدة ترشده وتعلمه وتلهمه. جامعة نزوى.
Dear audience and participants, it is our honor to welcome our distinguished guest, Dr. Abdul Aziz Rashid Al-Hashmi, to deliver his keynote lecture entitled Highly Demand Advanced Skills in Industry. Before handing the mic, I would like to give a short overview of the huge and research-filled biography of Dr. Abdul Aziz Al-Hashmi. He had his BSc in Petroleum Engineering from SQU in 1999, MSc in Chemical Engineering from Tulsa University, USA in 2002, and PhD in Chemical Engineering from Imperial College London, UK in 2008. He taught different courses during his employment in SQU. He served as a chair of Department Curriculum and Accreditation Committee from year 2014 to 18. Also, he chaired the Department Industrial Training Committee from 2010 to 2015. The outcome of his research projects published in 40 peer-reviewed journal papers, 24 conference papers, and 1 patent. He was awarded SQU Delegate Researcher Award in May 2016. After 20 years serving in SQU, he got employed in petroleum engineering by BDO since 2019. Dr. Abdul Aziz, the ground is yours.
السلام عليكم. بسم الله الرحمن الرحيم. بس شيل. Is it clear? طيب مش كويس. بسم الله الرحمن الرحيم. السلام عليكم. It's really a privilege to be here among the University of Nizwa in this symposium and to share my talk about the skills of the future, how different they are from the current and from the past. I will start with a quote from a book of higher education in 2040. It says that the university of the future will derive its right to exist primarily from being active in the world and by producing knowledge for the world. So universities, they have to think about the global context. And this talk will start with defining what is a skill and the skill gap. After that, we will go through the skill gap in Oman, which is the local context of this presentation, lifelong learning, and before concluding, I will go through how to bridge the skill gap in Oman. Here we see that the top 10 skills in 2020 and as compared in 2015. And you see that the first skill is really complex problem solving, which is the same since the beginning. Since 2015, it is the same. This is followed by critical thinking and creativity. So what is a skill and what is skill? A skill, as we can define it, is the ability to do something out of training, practice, and experience. It is very important to highlight the importance of that level of competency. It is coming out of training and practice. So, for example, if we have the driving as a competency, you will start with awareness and you will go into different levels of knowledge, and then by practicing it, you will get to the level of skill. And with that level, you can coach others in order to drive. So a skill, it is a level of competency where you can coach other to get that skill. Skill gap is really the mismatch between the demand and the supply. The demand by the industry and the supply by academic institutions. So there's a mismatch between these skills, and here we will talk about several causes of this mismatch. Why we do have that skill gap. The main cause of this skill gap, especially recently, it is the exponential increase in digital capacity and communication. And with that, it comes globalization. You see here, the bottom right-hand side chart, how technology is increasing with time. It is exponential. So technology is increasing with time as exponential, while the society and how we cope with that advancement, it is linear. So the gap between the technology and what is provided by technology is not really comprehended by society, and among society is our academic institutions. Then with that, it comes communication and globalization. And recently we have this COVID-19. So out of COVID-19, it is a proof that we are not living in silos. I mean, we are global in nature, and everything is happening around the world. It will affect you by the end of the day. A third cause is really, and it has been a dilemma or a challenge always, it is the communication between and the connectivity between academic and industry. How good we are into bridging the gap between these two? Are we talking? Are we implementing our ideas? Yes, during my work in Sultan Qaboos University, and now recently in academia and industry in petroleum development Oman, we have this connection with academic institutions, but are it at the level of the challenge? Because the challenge is high. So are we having this effective communication in order to bridge the gap? So this is not really special to Oman. This is global in nature. And everyone, if you go outside and research about it, you will find it everywhere. It is global. And so we have also relatively slow response of academic institutions to change in work environment. And again, it is related somehow to the connectivity between academic and industry. Here in the next 3 slides, I will go through outcomes of a survey, a recent survey done by Oman Society for Petroleum Services, OBAL, jointly with the Ministry of Higher Education. This is published and it's available online from the Ministry of Higher Education website, and it is published in 2017. For me, this was really informative. And by the way, this is related to oil and gas industry only. It is not related to other industries or government. Because oil and gas is representing the main income in Oman, and it's also representing the main employer for our graduates, especially in the engineering graduates. So it is employing around 25% of our all fresh graduates. Main outcomes I want to highlight is that 42% of workers in oil and gas sector have diploma and higher. Engineering graduates constituted around 86% of employed applicants. So mainly it's about engineering employment to oil and gas. The third point is very important, and I highlighted here that there is weak correlation between graduate GPA and employability, which is not new. A lot of people, they talked about it, but also it is out of this survey as well. That yes, advertisement in oil and gas companies is for applicants to have at least 2.5. But after that, what is judging their employment, it is the interview. So in interview, usually what we are looking for, I mean in industry, they are looking for some qualities in these students or in these graduates, like creativity, interpersonal skills, critical thinking, and communication. And I think this symposium is one of the foundation and really very, very important aspect to deliver these skills to our students. Because in these projects, people, they communicate, they tackle a problem-solving issue, they write in English, they present their work. So there's a lot of aspects really addressed by this very, very important symposium, which I wish it will continue and it will grow. The fifth outcome is that there's a need of training in pre-employment test and interviews, which I will highlight there. In the bottom right figure here, it shows that 54% of the one accepted by industry, they have a GPA between 2.5 and 3. So most of the employability is really to that range of GPA. It is not a 3 and above. Okay. Here, in that report, they are presenting the employer's response about our graduates from academic institutions. So what do they lack? This is the employer perspective I'm talking about. So employers, they think that graduates, they lack English language, which is really striking, because you know the medium of communication in industry is really English. So the first skill really is lacking is English. The second one is working under pressure. The third is interpersonal and communication skills. These are really the skills maybe I will highlight that it will help our graduates in order to get employed and after that to build their career. It is not just to have the entry point, it's also how to go into the levels in the industry. So it is very important that our students, they have these competencies or these skills: English, communication, problem solving, interpersonal communication. So what is important in the CV for our students? Of course, academic qualification. Do it diploma or bachelor or master or PhD. Professional development activities. In the CV, do I see, for example, the graduates, they have training, they worked on themselves in order to do workshops? Do they do, for example, this symposium, it will be beneficial for anyone to have it in their CV. Another thing is notable achievements, awards, for example, technical and non-technical societies, membership, project delivery. It is very important. For example, some students, they are involved in society activities where they manage budgets. So if I am interviewing somebody managing budget and project, this is a big plus for them. And membership in other committees, for example, within the university or outside. So these, they will help the graduates really to have employability in industry. Now, about the graduates' perception, it is within that survey as well, which is in line with what employers think about the graduates. So our graduates, they are delivering the same message, that they are lacking or they are short, not really lacking, they are short, most of them. 35%, they think that they lack, for example, English language skills. The other thing which is very important is analytical skills. What we expect from our engineering graduates is to have that analytical skills and problem solving, complex problem solving skills. Organizational skills, time management, it is the same which is highlighted by the employers. So I think the two things are really correlated: the employer perspective and the graduates perspective. Now, how we can address these skills and how we can improve it locally in Oman. One of the foundational and essential skills for graduates in any university is lifelong learning. Now, the university, I think it is the proper place where this skill, it is practiced. So if a graduate is saying to me that he practiced lifelong learning, it is true. Because they do projects, they do their assignments outside curricula. So in this figure here, you see that lifelong learning, it is encapsulating other skills. So 16 skills, they are within this lifelong learning skill. And lifelong learning, it will be in the future as well as it was in the past. So this is the main skill that we should empower our students and graduates to have. So what will help our students really to improve the skill set? It is very important to connect with academic advisor and have a mentor during your stay, for example, in the university. Sometimes we are not really fully utilizing this, whatever the university is giving us as students. Sometimes we lack into really utilizing it. So we have advisors, we have mentors, we have our peers as well. Also, be active in extracurricular, like societies, sport, cultural competitions, committees, symposium like the current symposium. I mean, being active in this, it will be really a plus for you in order to get employed and to build your career as well. seek formal and informal training, get membership in technical and non-technical societies, also utilize technical and social platforms like LinkedIn. So nowadays, I mean, our students, they are in a privilege to have online training, for example, online activities like the current symposium, where you can attract a lot of people from outside without coming here. We have technical platforms, social platforms like LinkedIn, where you can connect to others. You can build your network there without going anywhere. So LinkedIn, SPE, LinkedIn Learning, there's a lot of platform where you can get training certified. Really, you can have certificates. Be updated with the new trends. It's very important to, and this is one aspect of lifelong learning, is, for example, to know about what is net zero, blue and green hydrogen, which we are talking about now. GHG, which is greenhouse gases. And very, very important skill for the future is really digitization and automation. Because of the time limitation, I will go briefly through how we can really efficiently bridge the gap between or the skill gap. And I put here 3 stakeholders: academic institutions, industry, and students or graduates themselves, what they can do. And you can see that most of the points are for the students. If I'm not limited with the space here, I put other points for the students, really, because what I think it is mainly the job of the student and the graduate to work on themselves, to have ownership of their skills. So we will start with academic institutions, building agile curriculum, for example, and involving students in building this curriculum. So it is very important, because in order to capture this trend, upward trend of technology, the best fit is to have the young people. So the young people will really work in closing the gap. Involving them in building the curriculum is very, very important. Emphasizing on interdisciplinary projects like the current symposium, it is very important. Student alumni, encourage and reward students for their extracurricular activities. Secure training opportunities, which we talk about always, and it is one of the challenges we have, is to really secure training and proper training opportunities in industry for our students and graduates. Industry, they need also to include supporting academic institutions in their business KPIs, provide the necessary training, which is very important, provide the time, free some time for their staff in order to train students. Regarding training, support academic investments as investment, not a cost, and allow access to some data and information, which is very important. Students, of course, I mean, the list is very long. Ownership of their skill set is very important. Benchmark and evaluate, enhance their skills, because they have now a lot of platforms where they can do that. Get a mentor, join student societies, and I highlighted some of these previously. Get certification, build your CV always. Try to build your CV, improve it with time. Always go into interviews. So don't be hesitant to apply and get interviewed. This figure, which is here, is really about going out of the comfort zone. In order to grow, what you need to challenge your fear and really grow into the fear zone or learning zones in order to grow above your, and skill yourself. I will conclude here with some conclusion and recommendations. So one of the things that I want to highlight is that now it is the era of the 4th industrial revolution. And the means and the medium for this industrial revolution is data. We have a huge data, really. Even staffing is not sufficient to cope with this data. So in order to have this, what you need is to have data analytics, statistics is very important, digitization and automation, machine learning, augmented and virtual reality technologies to be embedded within our curriculum. It is very important, and I think a lot of universities, the University of Nizwa is doing this as well. And I saw the topics in this symposium, which are really addressing a lot of these skills within the symposium, which is really thrilling and fulfilling. Yes, there's challenges, but they are coming with their opportunities. Skills needed, to close the gap, they are matched by the training opportunities. There is a lot of opportunities already the technology is providing you in order to close the gap. Local and worldwide initiatives that I, for example, searched about World Economic Forum. They have a lot of initiatives for training and closing the gap. Also, there's a global council. Yes, there's challenges, but they are coming with where they discuss how to really bridge the gap and change the curriculum, for example. And last word for students and graduates is really that you are the leader of your future. So take ownership and build your CV, train yourself, skill, upskill, and reskill always. And the industry and all of us, we are here to support you. Thank you very much. Thank you, College of Engineering in the University of Nizwa, to allow me to have this talk, short talk, during this very, very important event. And I wish all the success to the university, the college, and the symposium. Thank you very much.
I would like to thank Dr. Abdul Aziz for this valuable, really, lecture and even advice for our college and for the student who hear this lecture online. And this is really addressed to all the students, not to only the student of the College of Engineering and Architecture. This lecture really, thank you very much, Dr. Abdul Aziz, and it encouraged us really to invite you again in the Engineering Open Day to address such a lecture and to present such a lecture to our students, inshallah, in the future. Thank you very much. Thank you.
Thank you again, Dr. Abdul Aziz. It is the time now for presenting a memorable gift to our keynote speaker, presented by Professor Hussein, the Dean of the College of Engineering and Architecture. We thank you all for attending the opening ceremony, and I would like to mention that the discussion sessions will start right now. Please join your assigned session per time. Also, I would like to bring to your kind attention that the sessions are open for all if you are interested to join any of them. Finally, please, I invite all to join the closing
Yes, doctor, we hear you. Of course, doctor. Wait, I wait, Ibrahim. Ibrahim, are you ready?
السلام عليكم. Okay. Few minutes. السلام عليكم. You can see the screen? I will share. Yes. Okay. Sure.
Okay. Bismillah ar-Rahman ar-Rahim. Hello everyone. Good morning. Today, my name is Musab Jama Al Marzouqi. Today, we're gonna talk about the methane pyrolyzed and steam reforming for the hydrogen production using cold flaget plasma. So, we're gonna start with the table of the contents, which is include introduction, methodology, and result and discussion and conclusion. So, we're gonna start first from the introduction. We summarize it to the methane. We're talking about the methane. So you know that methane is the toxic or acidic gas. So methane is the component with the synthetic equation CH4. So if each gas have effect and impact, so this we solve the problem. So we look for the effect of the methane. So the first effect is the methane contributed to the climate change, and it's able to trap the heat into the atmosphere, and then methane is released into the atmosphere has the disturbing effect of the ozone layer. So in this project we have a target, which is the target uh, to convert that methane, which is not good for the environment and not useful to daily life, to the economical component, or the component that have a benefit from it. So we convert it to the hydrogen. So the problem it is methane has ability to heat the weather 25 times stronger than effect of the CO2. So it's dangerous for the climate and the ozone layer. So the solution, we converted that methane to the hydrogen, which is useful in the economical sector or the industrial sector nowadays and daily life. So for the methodology, I will let you to listen, my friend Ibrahim.
Assalamu alaikum. My name is Ibrahim. Good morning, everyone, and welcome to our presentation. In this part of our presentation, I would like to talk about the methodology. I will start with the equipment and device that use it in our project, and we start with the GC. That means the gas chromatography. That device is micro GC fission and gas analysis device as measured and identify
Dr.
the
Ghazi
gas
and
by
Mr.
different.
Muhammad Ashraf, now you are co-hosts for this room. So please restart recording.
Excuse me. Doctor, I can complete or I don't know what's happening. Okay. Now this is the device that measures and identify the gas by temperature and density and volatility gases enter the device. And power supply, that is electrical device to supply the electrical charge in electrical load. And also the reactor, that's the like ball or tube that industry chemical reaction or place where the reaction occurs. And this is heaters and flask that use it to provide or to prepare the steam for our project. Now I will talk about the operating parameters. In our case, that work with the two variables, argon flow rate and the voltage, and we sum the parameter put in constant case and prepare more than 30 experiments, but we try to summarize it in 30 experiments to found the modeling for this project.
Ibrahim, you're left with only 5 minutes.
Okay. Here we talk about the experiment setup. We start with the variable parameters, and we found the hydrogen after all this process in our case. After that, we found the report from GC that describe the gases that produced from this reaction, and analyze this data and prepare in this case. Now we converted the data from the concentration to ppm to analysis, and now I will give my partner to show the first method result.
So we found that we found that data two method, which is method one include about the methane decomposition modeling. So this equation is the constant equation. We use it to the calculation the predict or the codec concentration. So we separated our result to two parts, to real and codec, which is hydrogen getting from the experiment 13 experiment. We converted by this equation to this value. So in the experiment number 8, as you shown here, we found the largest value of the hydrogen, which is 4,264 for the real and 2,875.5 for the codec. So as you shown in the this model or this chart, we reached the highest concentration. So it's applicable here. And the second method, I will let my friend to continue.
Here in second method, we do the steam reforming of methane, and we prepare the methane with the water vapor in plasma that we found this result, and we prepare the modeling to compare the result, the real result and the modeling result, and the modeling that help us to guide the result, how is it, and we found the highest concentration in our case also in the experiment number 8 that we found for 6,000 ppm, and that in our case. This is our conclusion. If you have any question, I am happy to answer.
Yes, my question for Ibrahim for you is like, as you mentioned the equation, like CH methane you used and you produce hydrogen and carbon, yes?
Yes.
But where is the carbon content?
Carbons is like solid particles. That's
It's precipitate in the reactor up down nano.
Because the GC just analyzes the gas.
What is the temperature of your reaction for this one?
25 degrees Celsius.
25 degrees Celsius.
Room temperature we work.
From where you get 25 degrees Celsius?
We work in the room temperature and we assume that temperature is in 25 degrees Celsius.
No, did you validate these things from any other previous experiment from the literature? Did you get any data 25 degrees is possible to produce hydrogen?
There is many of research about it,
but you have not compared. You have not shown. You have not shown here. It is like because 25 degree it is highly impossible to produce hydrogen. I don't know like how you produce.
Yeah, but with this the new technology that's called the.
So how you validate? That's my question. Is like how you validate? Where is the just show the where is the literature or something you have data from where you evaluate it or you have like compared, you validated this particular result because it is like looking like me like a fishy. It is not looking correct. You know this.
Doctor, it's a cold plasma. It's working under the 25 room temperature.
It's Ibrahim, not, but where is the validation? Where is a data for this particular one? From where you are comparing this particular one? You have any data to prove that whatever you have done it is correct?
There is not there is any data you mean, Doctor, but the GC that analyzed this.
Yes, I understand Ibrahim to you,
yes.
But the thing is that you have any like for example like literature or this one from where you can prove that whatever you have done it is correct or it is like close to the real that particular one. Because this is not the first time you're doing, okay?
Yes,
there are many people who are already done this particular thing. So where is your comparison? Where is your...
There is no comparison because this is just try or study how to convert the methane to hydrogen. How can produce the hydrogen from the methane. Not for this called comparison or like this.
Okay, how much was your input and how much is the output you get from this one? How much methane you take for and how much yield you get it? Because in your result you does not mention any units, how much amount it is you getting.
For the methane, we work in the we work in the BFR reactor. That means the continuous amount of methane enter the reactor, and the flow rate for the methane was 2 liters per minute.
Okay. And for what is for hydrogen, how much you produce from these 2 liters?
No, just I know the flow rate and I see if I can found the hydrogen. There is not to collect the hydrogen from the reactor, just to see if I can produce hydrogen from the methane by this new technology. I don't know really if I can it's called contain this amount.
Because Ibrahim, you already know we do material balance, yes?
Yes.
So for example, how much is your input and how much output you get it? So for example, you said 2 liters you're using methane. For this 2 liters, how much hydrogen you generate? Because you said in your this one, you use this particular source. Yes? This is a source. So how much hydrogen you get it for this one?
Here in our case, not to know how to what amount, just to know our study if you can produce hydrogen from this particular experiment.
Because you mentioned that, like for example, like the amount is produced.
Yes.
Like for example, you said in your slides, the amount is produced.
In our slide, we did this experiment and we see the result in ppm. That means the concentration of gases, not the amount of gases that in same content.
Okay, thank you. Dr. Kazi, if you have a question, you can ask.
Okay, thank you, thank you. Thank
You're
you.
welcome, Doctor. You're welcome.
Yes, doctor. Can you hear me? Okay. Hello, everyone. It's our pleasure to participate in relevant national symposium on engineering final year project. And me, Asila Abdul Aziz Khalfan al-Sheikhi, and my partner Fatma Abdullah Salim al-Yaqubi, we will present our final year project, which talk about effect of metal titanium dioxide composite for organic degradation. I will talk about introduction, methodology, and result and discussion. Finally, talk about conclusion. As you know, organic compounds are molecules that are carbon-based, and there is different of organic compounds in the environment, which come from factory waste, and some of them occurring naturally. Some of them. Can you hear me, doctor, or not? It's okay. It's okay. Some of them are toxic and harmful and considered major source of pollution. Factories suffer from the coloration issue, and there are several methods contribute to decomposition of the organic material, such as biotreatment, chemical treatment, and photooxidation that we used in our project. The coloration of organic compounds is considered as an industrial challenge toward environment, is caused to pollution. So science has found an environmentally friendly of a treatment method for the organic material by using titanium dioxide with UV light. But as you know, UV rays are harmful to the environment and to human as well. So many researchers have tried to use normal light with metals doped titanium dioxide for safe decomposition of organic materials. And the objectives of our project are, the objective of the study is to investigate the ability of titanium dioxide and titanium dioxide doped metals. We use Fe positive 3 and Co positive 2 under UV light and normal light for the treatment of methylene blue. And the second objective is we use different conditions being considered, such as methylene blue concentration, titanium dioxide concentration, metal doped concentration, and UV light intensity. Yes, Fatma.
Hello everybody, I am Fatima Abdullah Yaqubi. I'm complete to my partner Asila. I will explain the photocatalytic process. First, the photocatalytic process actually is the acceleration of photoreaction in presence of catalyst, and photocatalysis over semiconductors involve the absorption of light of energy larger their band gap, generated excited electron and positive hole, which generate free radical able to undergo secondary reaction. The process and mechanism of photocatalysis differ. They can summarize in 4 key steps. The first step is absorption of light to produce electron-hole pairs. Second, separation of excited charge. Third, transfer of electron and holes to the surface of photocatalysis, which is called semiconductor of the catalyst. Finally, utilization of charge on the surface for redox reaction. I will explain in detail for this mechanism for iron-doped titanium dioxide. The first step consists on the formation of Fe positive 2 ions that result by the transfer of photogenerated electrons from titanium dioxide to Fe positive 3 ion. And we know that the Fe positive 2 ion is relatively unstable compared to Fe positive 3 ion. Hence, the trapped charge can be released from Fe positive 2 ion and afterward migrate to the semiconductor surface to initiate the photocatalytic reaction. In this sense, Fe positive 2 ions can be oxidized to Fe positive 3 ions by transfer electron to molecular oxygen, which is actually absorbed on the surface of titanium dioxide to form superoxide anion, which is known as highly reactive oxygen species. In the meantime, Fe positive 3 ion can also act as hole trap because the energy of Fe positive 4 ion and Fe positive 3 ion is above the valence band energy of end-doped titanium dioxide. Therefore, Fe positive 4 ion can be reduced to Fe positive 3 ion by capturing electron, while the surface hydroxyl group transform to hydroxyl radical. We believe that the electron and hole scavenger ability of Fe positive 3 ion is the main feature. The same mechanism and the same step happen for the titanium dioxide. I'm not going to explain because I explained before to short us that time. And the same also things for iron and cobalt of titanium dioxide.
I will talk briefly about the photocatalytic reactor. The photocatalytic reactor consists of 1.8 liter transparent glass vessel and 2 UV lamps with a 3.281 milliwatt per centimeter cubic centimeter intensity were placed on the top of the vessel, and both the vessel and lamps were covered by an aluminum sheet to reflect light onto the liquid. The mixed solution of catalyst and methylene blue were circulated via immerse pump to the reactor via silicone pipes, and samples were collected every 30 minutes for analysis by using UV spectrophotometer. Firstly, we start our experiment with prepare the methylene blue solution, and then after that we start to prepare the catalyst. Firstly, we start with prepare the pure titanium dioxide catalyst, and this includes several steps. And then we prepare the Fe positive 3 titanium dioxide catalyst by using sol gel method, and this includes several steps also. After that, prepared the Fe positive 3 titanium dioxide catalyst by using the Wittenbergenation method, and this includes several steps also. And we prepared the CO positive 2 titanium dioxide catalyst by using the Wittenbergenation method, and this includes several steps also. And the last one, we prepared the Fe positive 3 plus CO positive 2 titanium dioxide catalyst by using the Wittenbergenation method, and this includes several steps also. Now I would, Fatima will talk about the result and discussion.
I will talk about result and discussion. Here, this is the scanning electron microscopy analysis at different magnification, which is 1,000, 5,000, 10,000. As shown in micrograph, the morphology of the titanium dioxide nanoparticle is generally spherical, and the nanoparticles are agglomerated together to create several nanoclusters. And these Next, Asina. And these are the SEM analysis of Fe doped titanium dioxide at various Fe positive 3 dopant level, which is 0.3 gram and 0.6 gram. Also, these are the SEM analysis of the cobalt doped titanium dioxide material at 0.6 gram of CO positive 2 dopant level. In addition, these are the SEM analysis of the Fe and cobalt doped titanium dioxide material at 0.6 dopant level for both of Fe positive 3 and CO positive 2. Next, Asina. And these are the graph of what we got it, which is the collaboration curve actually from the samples that we did, CT over C naught with time. The first one for the end of titanium dioxide. The second one is for Fe doped titanium dioxide use Solgen method. The third one is also Solgen method, but we use 2 gram of Fe positive 3. Here, the third one is for when we use the Fe with 2 dopant level 0.3 gram and 0.6 gram. For E graph is for when we use 0.6 gram of cobalt doped titanium dioxide, and we use 2 gram of titanium dioxide. The third one for the Fe and cobalt, we use both 0.6 gram dopant level and 2 gram of titanium dioxide. So here the conclusion. Actually, we achieve over 80% degradation when we use titanium dioxide. The amount is 500 parts per million. And actually, the best result we get it is around 65% of methylene blue degraded in presence of iron doped titanium dioxide when we use 1 gram titanium dioxide. Solgen method cancels. That's what we looking for, and this is actually our objective. And around 50% of methylene blue degraded in presence of 0.6 gram cobalt doped titanium dioxide under visible irradiation. And finally, 47% of methylene blue degrade in presence of 0.6 gram Fe and 0.6 gram cobalt doped titanium dioxide, also under visible irradiation. Thank you.
Yes, doctor. As you know, doctor, the factories suffer from the coloration issue, and as you know, the methylene blue is one of the strongest organic material in color. So it's difficult to decomposition this organic materials.
And doctor, also we want to degrade this strong material at visible light, not just we use UV light.
Yes. Yes, 2 methods, Solgen method and with impregnation method. To see to see the difference of the result which come from Solgen method and the with impregnation method. Yes, both methods.
Yes,
You.
yes. My question to you, Asila,
Yes,
is like
doctor.
is you have chosen, like as you said, it is more demand industry. So why you not taken industrial sample? Why you taken methylene this particularly one? Why you taken, because if it is available, you can take the source from industry. Why you taken this methylene blue?
As you know, Doctor, we research about the methylene blue, and we find the methylene blue is the strongest organic material in color, which I said before.
Yes,
It's the
but for how
strongest.
can you say,
Yeah.
because in
So,
from no no
so
uh,
to challenge our
because your result shows that nothing comparison. So for example, if you have done it, you have whatever things you are showing the results, there is no comparison from the previous studies, like what you did it is correct, or it is the difference from the previous study, from the other authors they have done literally like this particular one, because nothing comparison is there. You have done but two method, but there is no comparison. Can you understand?
Yes, Doctor.
Why you have not compared?
But
Because
Doctor, as you know, methylene blue, there are methylene blue has different uses in our lives.
yes, I understand, but thing is like when you put the results, when you are showing the results, the nature of the graph and other things, you have not put any comparison. The result, for example, you get some values. Now, what is like the value, whether you got it is correct or wrong, we don't understand like how you can compare this one. And this is not first study.
Yes, Doctor, we put it in the research in the final year project, not here in paper or in a presentation.
But it is needed here, because it is like, for example, like you have done this one, so like this is not first time you are doing. There are many people who have done this. This is not first fresh topic. This is very old topic. Okay, there are many articles available for this one, so you have like there are many things are available for this one. Yes, Fatma, can you answer?
Yes, Doctor. Actually, you are right. We are not the first one we did this project, but we know that since 1990, I think that they start to do this project, and until now they didn't found the exact, the efficiency that they want from to degrade the methylene blue. So until now, the researcher work to degrade more and more. They do it under UV light, and we want to achieve that. We want to degrade these things under visible light, not just UV light.
Yes, Fatma, my question is like, for example, like you got some result. So did you compare the result with that one, from the 1999 articles or other one?
No, because they didn't do under visible light. Some of them they do under sunlight, yes, but not actually the methylene blue. And methylene blue is the strongest one, and they only do it under UV light to degrade.
Because unless you are not comparing what you did, you cannot prove it is a correct or wrong. Okay, so you need the comparison to prove that whatever you're doing, because somebody will write something, he has done some experiment, he got some nature, but how can I say like this is true and this particular one? You need a validation. You understand? You need a validation. Yes, you need a validation for this one. Okay, thank you.
You're welcome, Doctor.
Yes, Doctor.
It's my screen clear for you? Yeah, sure. Yes, Doctor. Yes, good morning, ladies and gentlemen. I'm Anfal Al-Araimi, Process Operation and Maintenance Engineer from National University of Science and Technology. and it's my pleasure today to present in front of experienced doctors as you about my research paper under the title of Clean Energy from Plastic, Production of Pyrolysis Oil from the Plastic Waste. So we are all aware about Oman Vision 2040 that we have to diversify the types of income in Sultanate of Oman. Since Sultanate of Oman, it depends around 68% on the oil sector in its income or the total revenue. So our project will help to reach this goal and at the same time will help to overcome the threats of depleting the fossil fuel. However, it also will help to Oman Vision 2040 goals, achieving the goals that we have to use the sustainable energy. So I will cover today many points, starting from the abstract to the conclusion. So as you can see nowadays, the high demand on the plastic materials, and this is due to its unique properties. And you can imagine that in Sultanate of Oman itself, 20.9% of the solid waste it is from plastic. So it is a very high percent. So since the plastic it's produced from non-sustainable and non-biodegradable materials, it's contribute in many problems in our life, such as many types of pollutions, soil, water, and even air pollution. And at the same time, it contribute in plastic waste crisis and even in depleting the fossil fuel greenhouse emissions. So what is the pyrolysis process actually? The pyrolysis process of the plastic, it is a chemical reaction where the large molecules break down to smaller molecules by using heat source. So in our project, we conduct the pyrolysis process for two types of plastic, and this will contribute in the plastic waste management program and provide a clean energy from the waste itself. So the pyrolysis process have been found as an excellent solution that transforms around 80% from the petroplastic to a liquid oil. And in this study, we conduct for that two types of plastic, and we make the necessary analysis by using the GC instrument. The main purpose of our project is to give a deep understanding about the plastic waste and how we can benefit the society from this plastic waste. And this will be attempted by performing a recycling process into the low density polymers at a suitable temperatures and other parameters, so we can obtain the pyrolysis oil, which can be used in many applications in our life, such as fueling engine and boilers consumptions. So I made many literature reviews, and here the best important 5 literature reviews. The first one that shows using of catalyst increase the gaseous products and decrease the liquid oil. And the second literature reviews, which was done for Sherrod in 2016, shows that the suitable reactor can be used for the pyrolysis process is fluidizing bed reactor, and the suitable catalyst is FCC catalyst, which already we use it in our project. The third literature review shows that the catalyst reduces the amount of halogens in the liquid oil products. The fourth one shows that the continuous stirred tank reactor provide an effective mixing for a large particulate size distribution. And the last one provide that the pyrolysis process, it is a recycle process that can be done for the plastic waste and provide reach up the maximum environmental and economical advantages. The methodologies which we follow in our project, that we collect our samples from the plastic, two types of plastic, polyethylene, which can come from the body of the water, and high density polyethylene, which can come from the top of the water bottle. And we start to cut and clean the plastic waste, and we introduce the plastic waste into the reactor. Then after a certain time, around maybe 30 minutes, we start heating up the converted to the liquid. Then we collect our sample and we make an analysis. This is the concept model and the experimental setup which we followed. We used a pressure cooker which was worked as a batch reactor. Then we connect the condenser, and we start heat up by the hot plate to determine the quality of the fuel. So the fuel have more octane number, higher quality than others. And also the cycloalkanes category presented here as the cyclohexane. So it is the cyclohexane. It is found in natural gas, motor fuels, and even in diesel and other petroleum products. So this gives us a green sign or a good sign that this polyfuel can be used really in our life. About the polyethylene results, it shows around 18 peaks. So those 18 peaks shows different 18 hydrocarbons type, such as hexane, cyclodecane, and others. And these hydrocarbons in the polyethylene vary from C10 to C27. And the hexadecane, as you can see, it is the largest peak. Don't be confused, because the hexane, it is used as a solvent when we make the experiment. So we will not consider it. We will consider the hexadecane as the largest peak. So the hexadecane can be found in jet fuels, gasoline, diesel, and other heavy petroleum products. This was the end of the presentation, and I forgot to mention the recommendations for this project. So the best catalyst, as I said before, it is the FCC catalyst, and we can change the type of the reactor and use the fluidizing bed reactor. Also, we can change the plastic type. We can use the BS plastic type, which is provide like more conversion of liquid oil. And also about the heat source, we can reduce the gas emissions from the electricity and use a solar heat source. Thank you for your listening, and please feel free for any questions. Yes, doctor, but actually we use around 90% of the plastic waste or the feedstock and percent of the FCC. This is the feedstock. But about the amount, we faced like many challenges. There was many leaking because of the pressure cooker. So it wasn't that like accurate too much. So, but we collect like only small sample, but it was good for the analysis, for the instrument. And the pressure around 20 bar. Yeah, we fix like the pressure gauge thermocouple on the inside the pressure cooker to measure the temperature and the pressure. Doctor, no, because as I told you, it wasn't like that amount. It was only small amount, around 1 million. But we do the GC instrument analysis.
Alfal, for you, like my question is, you use pyrolysis. What is the temperature for pyrolysis?
It is depends on the types of plastic, but generally from 300 to 900 Celsius.
Okay, so and how much amount of energy you spend for this one? Because your process does not look feasible. You understand? The amount of expenditure you're going to spend is like more than the product you will get it from here, because you will have high temperature. Yes. And
Yeah.
Second thing is like that this is a plastic. Many carcinogenous gases will be released, which is like harmful to the person. So it is like people will not look for this particular technology.
Yes, doctor. No, this is technology is very, very important technology, and it is useful. But because we make it in the college, and there was no available like reactor. But when we made the literature review, that this pyrolysis oil have to be go for the refinery process, then they separate it for three products. Sorry. around 80% of
Yes,
the
and
oil.
for my question is like, if you see the literature, like in this particular process,
Yes.
there is when you're burning, or like, for example, when you're doing the pyrolysis process, in the breakdown process, there are different gases released, you know, and
Yeah,
there
yeah.
are very harmful gases for this one. And
It
the
is very,
temperature requirement is like temperature also, this temperature is very high temperature.
yes,
So it is not like economically feasible, but it is like,
it is,
yes,
it is
not.
one of the drawbacks of the pyrolysis process, actually, the energy consuming and the greenhouses emissions. But we recycle this gaseous, like around 20% of gaseous, it's go for its own applications, and 80% of the liquid go for its applications, and the remain 10% it's for the char.
Okay, like how you do the analysis for your like gases which is coming from this particular pyrolysis process? How you did the analysis? Tell me.
For my experiment, I didn't do analysis for that.
Okay, you didn't. You
But
have
in
not done
the
anything.
literature review, they made analysis.
Yes, but for example, if you have done, then you can talk. Yes.
Yeah.
Okay. Thank you.
Thank you, doctor.
Yes, yes, doctor. Ciao. Okay, doctor. Hello everyone. My name is Moza and my classmate is Mona Al-Ma'mari. Today, inshallah, we will talk about the intensification of the gases produced from H2O and CO2 plasmolysis. Firstly, we know we have many gases in atmosphere, such as carbon dioxide, methane, water vapor, and sciences gases, and other gases. But the concentration of these gases is increased and changed because many reasons. For example, human industrial activity and natural phenomena such as fire and volcano. Okay. We use this reactor, multi-flying reactor, um, to get this. Okay. This gases
Musa, your
This
slide is not moving. Your
not
slide
move.
is not. Yes.
Oh, okay. Wait, Doctor.
And you have to be fast, Musa. Like you have already finished 4
Yes,
minutes.
yes, Doctor. 1 minute, Doctor. Now, Doctor, it move.
Me, this nothing is appearing.
Ah, okay. Okay, Doctor. Now, Doctor. We used this reactor, multi-flying jet plasma reactor. The plasma is enter into two holes. This holes for plasma, and the other hole is filled with a mixture of water vapor and carbon dioxide. On the other hand, argon gas is introduced, and the other hole for connected the gases. This argon gas for gas chromatography need argon to detect the gases we produce. And we have also other detector for hydrogen and gas leak detector. Also, we used experimental design to analyze the result. Okay, and we do 13 experiments and analyze it to a model, and we have this equation for model, and Mona will complete. Classmate Mona.
Assalamu alaikum. My name is Mona Al-Mamari. Today I will complete with my friend about the result and discussion of our research. So, water vapor and CO2 in plasma reaction. When we did this reaction in multi-flying jet plasma reactor, we put plasma, CO2, and the water vapor. We do this reaction and output connected in gas volumetric to detect the gases, and analytic we measure the concentration of hydrogen. Where we do this experiment in different conditions, and the result of process is found to be affected by two factors, voltage and flow rate of argon. And we use the rotator center composition rotator design method to do this experiment, and we do 13 experiments. This method help us to reduce the number of trial and easy way to analyze data. So we get from this experiment and the GC present the amount of hydrogen in in mole, but our production in hydrogen from experiment get in this table show in experiment 1 298 ppm and experiment 2 1352. So in this experiment appear from us in producing amount of hydrogen. The next slide. Next, Moza. Moza, next slide.
Okay, ma'am. Clearly.
Yes, you finish, Mona?
No.
This.
After we found the result, we did analyze for the result to find model that we help us to compare. Then next we calculate the amount of hydrogen by use this model and to compare the results. Next and this results, and but then we calculate the error, and there are some error because some reasons, and this chart appear as the chart appears the difference between experimentally and when calculate from the model. This experiment help us to solve the increase in greenhouse gases, so reduce for the global warming. And we did this experiment at a good quality and lower cost and shorter time, also save the energy. Thank you. That's all. This is for model code. We use central composition rotator design to get the model. This is only code. Yes. Yes. We
Yes. Yes.
You see chromatograph to detect the gas and analyze. Really, you see. Yes, to analyze and measure the concentration of gases.
Yes. I have like number of questions for you. Like my first question is like you have used, like you said, a production of different type of gases. So apart from hydrogen, which other gases you have like seen this particular one? Can you mention? Because you're using GCS.
Yes.
Yes.
So did you measure the other gases which are being present there?
We produce gases and other gases of hydrogen, but we concentration in hydrogen because another gases is not more, only some gases.
What about like your what is the
percentage.
source for this your gas production for hydrogen production?
Like
For your hydrogen production, for which is the input? What is the input for your hydrogen production? What is the input gas?
CO2 and H2O vapor. Yes.
H2O. H2O means water?
Water vapor.
Yes, water vapor and CO2.
Okay. What time,
Mixture.
at what temperature the water splits to produce hydrogen? Did you know?
Maybe approximately 3 minutes.
No, temperature. At
Temperature
what temperature?
at room temperature.
Are you
Because
sure? Are you like
yes,
it is going to produce hydrogen at room temperature at 25 degrees Celsius?
yes, because
Yes.
we use cold plasma.
So
Yes.
how you validate this particular thing? This is not correct. For your information, it is not correct. Please check from the other data. You can read it. It is not the true part. Have you validated your data, these particular things? Have you validated
What
anything?
dictator?
Have you validated your result from this particular any part? Did you do verification what you have done? It is from the previous studies, literature, any
No,
literature you have done it for this particular one, any literature?
no.
Okay, thank you.
Welcome. السلام عليكم. Not sure. Okay. السلام عليكم. I'm now الراسبي, chemical engineer from the National University of Science and Technology. It's my pleasure to show you my work in this research, petroleum refinery water treatment using silica nanoparticles. This is the content which I will go through during this presentation: introduction, research problem and methodology, study model experiments, result and analysis, conclusion, and finally the reference. So, as you know, the effluent discharge from the enhanced oil recovery process contain a considerable amount of an organic, which create an environmental and health risk.
Dear
According
students,
to
your
the,
slide is not moving. Can you just...
yeah, it's not move.
Yeah.
Okay. According to the statistic prepared by BDO, there is around 8 to 10 barrels of oil water for every barrel of oil. Imagine that the huge amount of oily water produced in our environment and affect our environment. Therefore, the current research focus on the house synthesis of silica nanoparticles using environmentally friendly method. One of the challenges in employing silica nanoparticles is in the wastewater treatment process is the high cost. So we use an environmentally friendly method or a house synthesis, silica nanoparticles, synthesis of silica nanoparticles. This is the, yeah. I already, now. Okay, thank you. The material used in synthesis of silica nanoparticles are ethanol, ammonia hydroxide, tetraethyl orthosilicate by using a stopper method or stopper protocol. After mixing this materials, we centrifuge it and dry it to have a solid nanoparticle, so we can characterize it using a scanning electron microscopy, Fourier transform infrared spectroscopy, and X-ray diffractometer. In the batch absorption study, we conducted by performing a series of experiments by verifying the effluent solution pH,
Dear
staying
students,
time.
your slide is not moving. Please, the slide, like you are stuck in one slide only. Yes.
Okay. So the batch absorption studies were conducted by performing a series experiments by verifying effluent solution pH, stirring time, stirring speed, dosage of nanoparticle in the reduction of COD or chemical oxygen demand from the petroleum refinery effluents. The percentage reduction in COD was measured by using a thermoreactor. This study model or absorption study, we go through it during this work: solution pH, contact time, dosage, stirring speed, and finally we compare the result to select the optimum condition in this work. Now the most best part or the most interesting part is the result and analysis. The results show that the silicon nanoparticles were successfully synthesized. The surface
Dear
characterization.
students, the slide is not moving. You just get stuck in between. Like this presentation mode put it. Put the slides show. Just click on slideshow.
No.
Make it slideshow. You understand? Like because it gets stuck for this one in between.
Yeah, I make it a slideshow.
Yes, okay.
Now it's show.
Yes, yes. Now it is showing, but it should be moving. Just please be careful when you're.
I don't know why. Maybe the internet.
No. Because you are not moving. When you press the button, like you are moving the slide from this side. From the
Okay.
sidebar. You are not moving from this
Okay.
side.
Okay, sorry. So the results show that the silica and silicon nanoparticles were successfully synthesized. The surface structure and identification of functional group were carried out using SEM and FTIR, and phase identification and grain size was performed using XRD. Figure 1, as you can see, show you the SEM micrograph of silicon nanoparticles are very fine and appear to be distributed without any agglomeration, and it's in spherical shape with a size of 100 nanometer. While figure 2 show you the EDS spectra of silicon nanoparticles. Here we can see the high purity of silicon nanoparticles, a strong peak of oxygen and silicon. Figure 3 and figure 4 show you the FTIR spectra and XRD spectra of silicon nanoparticles. We can see a different peaks due to the mass of the nanoparticles. Here we can see a figure for the effect of verification of parameter on COD reduction or chemical oxygen demand. I already clicked it. It's okay? Okay. Here we can see a figure for the effect of verification of parameter on COD reduction. From the figure, we can know the optimum processing condition, which are here 8 pH, 19 minutes of contact time, 0.5 gram of dosage, and 120 of steering speed. In conclusion, silicon nanoparticles were successfully synthesized using a fission method or a house synthesis method, and the particles were employed in the reduction of organics from the oily water. The best processing condition obtained were pH 8, steering speed of 125 round per minute, mixing time of 90 minutes, and dosage of 0.5 gram. The outcome of the experiment showed that silicon nanoparticle is stable for removal of organics from refinery wastewater. The reference which we work on it during our work. Thank you, and if you have any question, please ask. Yeah. Yeah. Yeah, yeah. Mm-hmm. Yeah. Produced water. Yeah. Yeah. I am already now looking for a sponsor to do my work in the field, so I can have many samples, and I can work on it. Yeah.
Okay, these parameters which you can you hear me? Can you hear me?
Yeah.
I have like the parameter of this particular petroleum waste water. What are the different parameters you measure?
Here. This?
Yes, like for example, you have taken the sample. Yes,
Yeah.
initial sample.
Yeah.
So what were the pH and like as you said, like COD, BOD, all the things like COD you said here. So did you measure all these things? Where it is the
Yeah,
values?
it's already here.
Okay. So initially of this one.
Yeah.
After reduction, how much it is coming?
After what?
After like when you did treatment, initial sample is there, you understand?
Yeah. We do a different batch experiments, so we can select the optimum processing condition due to the COD reduction.
Yes, I mean, I'm asking like, for example, like in the sample, initially you have something,
Yeah.
yes?
Yeah.
After that, like you treat it and you get some values. So how much is that values? You have some pH, other things, you have done something?
Yeah, I do it, but I don't know which.
You have not compare anywhere, like for example, this initial parameter and after treatment, you get this one. You understand?
Yeah. This is the optimum process condition effect.
Yeah, I understand this one, but I'm
I
asking you
know.
like,
You mean the initial one?
yes, I
Or
need
I
to,
doing the treatment? No.
yes.
No.
Okay. And like you have taken silicon nanoparticles, this one,
Yeah.
yes?
Yeah. I synthesized the silicon nanoparticle.
Yes. What about other things? Can you use other things also
I already
apart from this one?
I already synthesized silicon nanoparticle and calcium carbonate nanoparticles. But when I compared the result, I found that the silicon nanoparticle is more effective because of its excellent biocompatibility, thermal stability, low toxicity. So I select the silicon nanoparticle.
Okay, thank you.
Thank you.
Yeah, now I will present. It's showing or not? What about now? It is stuck. I don't know why it's not showing. Is now showing or not? It's showing now? Yeah. I click. No, it's not working with me. I don't know why.
Or you can do one thing, you just again log in and come back to this one.
Okay. Okay.
Yes, Doctor, I'm with you. Bismillahirrahmanirrahim. Welcome everyone to my presentation. My name is Hagar Ahmed Lizami. The team members of my project is Ms. Khadija Al-Blushi and Dr. Geeta. I am from National University of Science and Technology, College of Engineering. My program is Process Operation and Maintenance. This project was under the supervision of Dr. Geeta. My title of my project is Calcium Carbonate Nanoparticles Meditated Treatment of Grey Water. Let's move to introduction. So, as we all know that gallons of grey water is thrown out of homes on a daily basis, which result in the discharge of a considerable amount of water. which is in turn leads to environmental pollution in the long run and also results in increased water consumption. The reusing of this grey water is a possible solution for irrigation water requirement. Hence, it's also essential to use a water treatment way to convert this grey water into a clean water for external use. My aim of project is to explore the possibility of reusing grey water after a proper treatment with nanoparticles. Especially, I treat the grey water with calcium carbonate nanoparticles and then I reuse it again after treatment. It can be reused for toilet flushing, watering plants, and also cleaning and other purposes. The project objective is main four project objective. First, to collect and analyze the grey water. Second, synthesize and characterization of these nanoparticles. Okay, and then to perform batch treatment of grey water using nanoparticles, and finally to characterize and analyze the grey water after the treatment. Now I will move for a schematic representation with the main materials I used in the project. As we can see, I used two main materials, which is sodium carbonate and calcium chloride. And I choose the water sample, grey water sample from the kitchen sink. So this is the schematic representation. First, collecting the grey water sample, which is from the kitchen sink, and then move to characterization and analyze it, and analyze the sample. And then we will move to nanoparticle synthesis. In the other side, we prepare the nanoparticles by mixing two materials. Which is sodium carbonate and calcium chloride, to make calcium carbonate nanoparticles. And then we make the characterization by using SEM, FTIR, and XRD, and then we will move to batch treatment. So the methodology, which is first calcium carbonate preparation, as you can see in this chemical reaction, it will give us calcium carbonate. Calcium carbonate nanoparticles were made by using precipitation and homogeneous method. The result and discussion. There's the two tables showing us the reading before treatment and after treatment of a grey water analysis. I measure different parameters. First, pH, COD, total dissolved solid and total suspended solid, also dissolved oxygen and turbidity, and finally conductivity. So first, as we can see, the pH changed. Before treatment was 5, and after treatment it becomes 6. So the original number of pH of original water is 7. So it's showing us the successful of this experiment. At COD, it will reduce from 1,814 to 235. And also TSS, TDS, DO, turbidity, showing us the decrease in the numbers. Also the conductivity. Now we will move for synthesis of calcium carbonate nanoparticles and to see the characterization of these nanoparticles. First pictures. This analysis was used, which is FTIR, which is for your morphological characterization of calcium carbonate nanoparticles by using SEM. Which is scanning electron microscopy. This device showing the composition of materials which is contains in these particles. And finally, the last one is X-ray diffraction. X-ray diffraction was used to investigate the crystalline nature of calcium carbonate nanoparticles. Now we will move for the batch treatment of calcium carbonate nanoparticles to see the effectiveness of variation of many parameters. Let's start with the first one, which is pH. So as showing in the figure, the effect of pH, the effectiveness of pH was increased in pH 8, and also we can see the COD, DO, and DO, TDS, TSS turbidity in when we increase the pH, the reduction will be increased. Second is effectiveness of steering time. Second is effectiveness of steering time. When we choose the steering time, another parameters will be same, and the only one will be changed is the time. So the pH was here 10 pH, and the steering time we varied from 15 to 120 minutes while steering the grey water sample. Then we will move for effectiveness of the steering speed. The second figure. Effectiveness of the steering speed also we variate this, but the other parameters will be same, which is the dosage will be 0.7 gram. Okay, and keeping the other parameters constant. As the result showing the optimal speed was found to be 125 RPM. The last figure, which is the effective of variation of nanoparticle dosage. We varied the dosage from 0.1 gram to 0.7 at optimum pH, steering time, and also steering speed. And the characterization of grey water after treatment will be showing like this figure. Finally, at the conclusion, calcium carbonate nanoparticles were successfully synthesized by using a simple and cost-effective method. The nanoparticles were characterized by using scanning electron microscopy, also Fourier transform infrared spectroscopy, and X-ray differential. And the batch treatment study were performed by using the synthesized nanoparticles by varying grey water solution, pH, steering time, speed, and also the dosage. The effectiveness of these nanoparticles in removal of pollution is accomplished by measuring the COD and also TDS, dissolved oxygen, and turbidity. The optimum processing condition where pH was 8, also steering speed 100 RPM, steering time of 16 minutes, and the dosage of calcium carbonate nanoparticles were 0.7 gram. So the outcome of the batch experimental study was attractive, and the treated water can be reused for irrigation purpose. And so reusing this grey water would be extremely beneficial for the world, and the developing countries can efficiently implement these simple and low-cost treatment techniques. Thank you for your attention. Yes, there is another nanoparticles, but I choose this because it's highly available in the environment, and we can easily get it from the environment, and also to treat with it. So there is no dangerous when you treat with this sample. Yeah. Yeah. Yes, because nanotechnology is new technology. So when we compare it between the traditional technology, it will be highly beneficial. And as we know that nanoparticles has small size and and huge area. So by this we can save money, save places, uh, like that. Hmm. Yes, but not in water treatment maybe, or especially in grey water. They use the nanoparticle, especially it was a new technology.
Yes, but it is like if it is a new means you can put for pattern. It is not new for your information. This is not new for the topic. Many work are done. If you type on the internet, you will get many things. Okay, for your
Yeah, but
information.
I mean the application of it. No, there's no much application for nanotechnology.
Yes, but when we speak, we have to speak correctly. Yes.
Okay, sir.
Yes, yes. So my question is like you have done for this gray water. Yes. You
Yeah.
have taken from the your household sample and other things
Yes,
like
kitchen sink. Yeah, from my
yes
house.
for kitchen sinks. Yes. Did you why not try it from like the other waste from colleges or the things?
Um, why I choose from my home?
Yes, it's not from other sources like from the canteen or the things.
Because I want to know the percentage of oil of this pollution in the water, like that,
Mm. Okay. Did you know like as you said like the
and the
pH is
efficiency.
the pH which is for the discharge is 6 pH. Yes. The
Yes,
the
before.
pH for the inlet would yes before it was 5 and after
Yeah.
treatment it becomes 6. Yes.
Yes. Yes.
Did you know like in Oman what is the regulation for discharging the pH for the water, gray water, waste treated water? You have any information? For
The
example, if can you discharge this water in a open sea or the things you have?
Yeah, I have read many journals which is about the irrigation um, of water. So what is the analysis of water which can be used for irrigation? So it's shown that from 5 to 7. So it will be suitable to use. It will if it is 6.
Okay, what about like your you have not shown your diagrams like process flow diagram how you have done this. This is like how you have done.
Because there is a limitation in slides. It's only 10 slides.
But you have to show because you've directly gone for the results. You understand, correct?
You mean pictures of what?
Like for example, your process flow, how it is like after, for example, you've taken the gray water and then you have directly gone to the results. Yes,
Yeah.
there was no nothing mentioned like.
Yes, I'm ready. Okay. Is it shown or not? Can I send it to you, Doctor? Okay. Yes. Yes. Okay. Thank you. Sorry for that.
Yes, I'm here. Could you give me a moment so I can check my speakers? They're not working very well. Could you give me like 5 minutes or 2 minutes?
Yes, I'm ready. Should I start? Yes. Do you imagine the impacts of the capsules in our body, especially for elderly or people who take capsule regularly? Side effects can be very greatly. They range from many spectrums such as nausea, hardness, or skin rash to more serious side effects like heart rhythm disorder. So, this research project aimed to develop an efficient drug delivery system using natural degradable biopolymers for combating infection caused by bacteria. I'm Sarah Shukeli from National University of Science and Technology. The aim of this project is development of natural degradable nanocapsules for drug delivery of antibacterial drugs. This and size distribution of the synthetic silica template using scanning electron microscopy, X-ray diffraction, Lorentz transfer infrared, spectroscopy, and zeta potential management, then to carry out the coating of the template using oppositely charged carboxyl methyl cellulose and chitosan polymers, followed by dissolution of the coat to obtain hollow capsules and its characterization, and then to perform drug encapsulation and release studies from nanocapsules by varying parametrically of the capsule wall at different pH temperature. Then moving to material and methodology. For preparing this nanocapsules, we use four experiment steps. First step to synthesis of the clouded template, then coated particle preparation, then cryo dissolution and hollow capsule preparation, then drug encapsulation and release study. The material used for synthesis of the clouded template and hollow capsules are ethanol, distilled water, ammonia hydroxide, tetraethynyl ethylate silate, and carboxyl methyl cellulose and chitosan, sodium hydrochloride, hydrofluoric acid, and hydrochloric acid. And for antibacteria drug, we used drug encapsulation was ciprofloxacin hydrochloride. The methodology implied in synthesis of the clouded template are Cipro process, and development of the nanocapsules are made through the dop coating method, followed by cryodesalination. So the loading and the release of a drug was carried out by adjusting the permeability of the capsule wall by manipulating the solution pH. So the characterization technology employed are scanning electron microscopy, X-ray diffraction, flow transfer inference spectroscopy, and UV visible spectroscopy. Then moving to result and discussion. Okay. As you can see from the first picture, they are thick, milky solution, which that indicates successful synthesis of the clouded particles. Here, A is before centrifugal and B after centrifugal. And the picture 2 represent the microstructure feature of the clouded particles. And the SEM micrograph revealed that the particles were dispersed without any aggregation, as you can see, of course, and the spherical national with the solid core around 300 nanometer in size. Yeah, still here. So moving to the third picture, the X-ray diffraction show that you can see here the peak is corresponding to 50, confirms the successful synthesis of the clouded nanoparticles. And finally, the spectroscopy analysis of the sample was analysis using FTR spectroscopy analysis as shown in figure 4. Moving to result and discussion of preparation of the coated particles. Could you please move it to the other side slide? Here, the coated particles, as you can see from figure 5, seem to be higher in the size compared to the template, and the diameter of the coated particles was nearly to 320 nanometer, which that indicates successfully deposition of the cathodic and anodic polymers on the template surface. So the scanning electron microscopy was used to analyze the surface microfilm of the coated particles, and the FTR spectrum of coated particles as shown in the figure 6, the highest peak corresponding, you can see that the wave number range between 2040 centimeter to 2000 centimeter corresponds that formation of the layer on the surface silica of the nanoparticles. It was be successfully. Moving to the cryodesalination and hollow capsules, here the cryodesalination was occurred out of the presence of hydrofluoric acid. Actually, we use 0.5% of the hydrofluoric acid, and the result hollow capsules were characterization using SEM. The capsules were formed and distributed uniformly without any regression, and the wall material was successfully formation a hollow capsule. Moving to the drug encapsulation. Here we have, from the picture 8, we have that vibration of the ciprofloxacin hydrochloride loading with the time. So the drug encapsulation process was studied for a period of 90 minutes. So the drug loading profile indicate that encapsulation, as you can see, is it's increasing with the increasing in the loading time, and the maximum encapsulation occur at 60 minutes. Here, the picture 9 is showing release profile of the drug from encapsulated at different pH water. The pH water, we use it 2 and 6 and 7.2 at temperature 36 degrees Celsius. As you can see here, the maximum release, it happened at 2 pH. So that is the perfect time to eat this capsule after eating food. And then finally, the carboxyl methyl cellulose chitosan were absorbed through a scanning electron microscopy after 80 hours of a drug release study, and the result showing that the capsule were broken and did not have the same wall thickness as stability as the original capsule, and this is natural because they are partially aggregation of the capsule were seen during the Ftir release condition. Moving to the conclusion. In this research, clouded particle of size around 30 nanometer was successfully synthesized by Stubber technology. This silica particle have been successfully emptied as a template for the preparation of the national degradable nanocapsules for sustainable drug delivery application, and the oppositely charged natural polymer used in the fabrication of the capsule wall are carboxyl methyl cellulose and chitosan. And the antibacterial drug we used, superfluoxetine hydrochloride, was successfully encapsulated into those capsules, and encapsulation drug was released in the Virtual model using water as released media. Of course, this research will provide the pharmaceutical needs of the people of Oman from the local source, as well as reduce the cost of importance and attract international experts. The synthesized nanocapsule over a cost-effective and environmentally friendly approach to the current technology utilizing biomaterial as a capsule wall. Introduction to this type of technology in drug delivery application holds the biomedical interest because they can use it for controlled release, targeting of the drug against the protection of enzyme, for example, protein, and that's it, and so on. So these substance without any side effects, by consider the benefits of each type of capsules, it's highly recommended to use natural degradable capsules instead of the capsule made from plastic or synthetic material. And that's it. You mean after release it? We take. Yes, 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 it's real. Ac- Actually, I sent the sample for SQQ, so they analyze it there.
Yes, I have a question for you, Sarah. Can you hear me?
Yes.
Did you compare your results? Because you have done from the various analysis, FTR, other things you did it, yes?
Yes.
Did you compare the results? And you said you did the testing in the water you use, yes?
Yes. In the
So
different condition of the pH in the water.
yes, yes. So where is the result for the water? Did you put that for water?
No, you mean before and after?
Yes, for example, like drug delivery as a medium of the system, you use water, yes?
Yes.
So you have any other information, how you measure the velocity and other things there?
No.
So then how you can say like you have delivered that particular one?
Actually, after encapsulation, we put that sample in the water in different pH condition.
Okay, but you have not delivered in the system, yes? It's not.
Yes.
Okay, because your title is delivery, yes?
Yeah.
So it's look like the curiosity, like something like some movement will be there, but you said it is a PH only. Okay.
Yeah, we use the pH is like we know what's the stable time for taking these capsules. Is
Okay.
after or before eating food. So
Okay.
based on that, the result show is the perfect time is at pH 2, so after eating the food.
Okay. Another question is like you use like number of things like in this particular one, different measurement. Yes, FTR, other things. This particular one.
Yes.
So are you trained in the previous one, or you directly somebody has done this analysis for you?
No, I didn't train. Someone else has helped me. It's
Okay.
actually we take the sample to SQ, so they are do it for us
Okay. Thank you.
because we take it in COVID. That's why.
Thank you.
Okay, thank you.
Yeah, should I send you the PPT? Is it visible? Okay. So, esteemed guests, Assalamu alaikum and a very good day to you all. It's a pleasure for me to be able to present my work with you. And without further ado, I'll start. Our project involves the refinery wastewater treatment using biochar derived from municipal solid waste. This was done as our final year project under the supervision of Dr. Geeta. As you can see, in Oman, we have a problem with waste management systems. With over 5,000 tons of municipal solid waste are being produced every day that are spread across 200 dump sites and over 4 engineering landfills. This is a problem because landfills are associated with greenhouse gas emissions, leachates, toxic leaking, and they can even cause fires from the chemical compounds that exist in the landfill. As we see recently in India, this occurred. Now, our project aims at treating these research problems that are involved in Oman, which is lack of adequate waste management system. But not only that, we try to provide a product that can be used after the reduction of municipal solid waste, which is activated carbon that we try to use in the refinery wastewater treatment. Now, as you can see, the landfills are associated with harmful pollutants. They have emissions and a lot of problems. Now, what we aimed is we wanted to take the solid waste from the municipal solid waste, convert them to biochar using a process called pyrolysis, and after that, performing chemical activations to get activated carbon, which was finally used to treat wastewater treatment. In doing so, we aim to lower the dependence of landfills within the country, reducing the emissions from the landfills, and obtain a value-added product from the municipal solid waste that can be used in further applications, secondary applications. Not only in just refinery wastewater treatment, it can be used in gas scrubbing and multiple other processes. Now, for us, we visited the Al Amrat landfill, which you can see from this picture over here. This is the Al Amrat landfill that we visited. The samples we took were some PVC pipes, plastic bottles, plastic wraps, lignocellulosic fibers, some papers and cardboards, and we brought them to our college. From here on, we reduced their sizes by shredding and cutting and grinding, and we placed them in a furnace. This is the furnace that we use. Over here, we placed the furnace and we performed pyrolysis. Without the presence of oxygen in an electric furnace, this occurred at 550 degrees for 2 hours. After the 2 hours, we let the machine cool down before removing the product, which was obtained is called biochar. As you can see from this image, this is the biochar we obtained. Now from here, we sent some samples for the SEM and the Ftir analysis, which I'll show you the results later. But after obtaining the biochar, what we decided is we activated it using chemicals. So we took a potassium hydroxide pellets and we dissolved them in water in the ratio provided in the slide, 30 grams in 1 liter of dissolved water. Then we mixed with the biochar in 1 to 4 mass ratios. After that, we let it sit under stirring for 48 hours so that the activation process could occur and the biochar could obtain pores. After the 48 hours, the samples were removed, they were dried, centrifuged, and since we used potassium hydroxide, we wanted to reduce the pH to a 7 pH. So we with water and hydrochloric acid. Then we turned it to the dryer one more time so that we can obtain a dry product, which could be used for the wastewater treatment. Now, the final product was used in batch treatment, where we obtained the wastewater, and we mixed a sample of the activated carbon with the wastewater, and under constant stirring, where we analyzed DOD, TSS, TDS, and COD for the sample, and where we also performed parametric analysis like effect of pH, dosage, and stirring time in order to determine the best possible conditions for us to operate in. Now for the results, as you can see over here, these are the SEM pictures before and after the activation. The left one is before activation. As you can see, it's kind of solid and rigidly, and it does not have any pore spaces. But when you look at the image on the right-hand side, you can see there are a lot of pore spaces, and the substance has obtained a globular shape. The globular shape means that it has active sites for capturing any material from the wastewater. And after we treated it to the wastewater, we took it for an SEM, and this was the image obtained. As you can see, there are a lot of particles that are embedded on the surface of the activated carbon, proving that it was successful to treat substances from the wastewater that we use, and that it could be applicable in the treatment of wastewater. But not only that, we also went for Ftir analysis. As you can see, this is the biochar Ftir analysis. There are multiple peaks. The peaks are due to because we use multiple different samples from different origins, like the cardboards and plastics. But after activating, you can see the samples, the peaks reduced, meaning the pore spaces were available in the activated carbon. Then after thermal treatment, some reduced also because of the thermal treatment removed the volatile compound. Then after treating with wastewater, you can see some multiple more peaks arrive, meaning that it was able to capture some compounds from the wastewater treatment and be able to absorb them. Moving on to the effects that we did the parametric analysis, this was the effect of pH. And if you look at it, we observed that the best optimum pH it would work under was the pH of 10 because this had the lowest amount of COD involved after the treatment of the water, and the TSS and TDS were also low. When we did the effect of stirring time, we observed that the best stirring time was 40 minutes time. That's where it was effectively working. And for the dosage, we observed that 1 gram of the activated carbon with 100 ml of water was the best possible outcome in order to obtain a higher capturing capacity. And this is all. Thank you very much. It was a combination of both actually, because physical involved using the heat and thermal treatment, and chemical activation was involved using potassium hydroxide and hydrochloric acid in order to compose the biochar. Yes, yes. Since we tried it, so it occurred, and we're still moving on to other parametric analysis. But as the results show so far, is that it was applicable, and it was able to cure us the wastewater treatment we used from the SEM, FTIR, and all the parametric analysis that we did. Could you speak up? I can't hear. I can't hear. I really can't hear. Yes, when you come to understand about feasibility analysis, is that first of all, we wanted to test if this project will actually work since it hasn't been done. For now, is that we understood that it works and that we're actually doing the feasibility analysis. But when you come to look at the bigger picture, is that this involves the whole country. So funding is not an issue, since we're also being contacted with the company, and they are actually amazed with the work. So I think municipal money can help, and it doesn't cost as much as the current processes that are used, because the current processes that are being used to treat the municipal solid waste involves using mycobacterial organisms, and these ones actually are costly in microbial treatment. So this offers a better solution.
Yes, like I have like for you one question. What is the drawback of this process?
The drawback is that I'd say it requires a lot of electricity, because we said we are using 5,000 tons a day. We are making 5,000 tons of municipal solid waste a day, and using an electric furnace, that will require a lot of electricity. But we have also mentioned that we are improving this project, so we are going to use renewable energy resources such as the wind and solar. So this will effectively cut down the cost for electricity. But even so, we can say this is one of the drawbacks, that it can consume a lot of electricity. But we also found out that during our pyrolysis, there's the biogas being produced. That biogas can be used to produce electricity, which will further reduce the cost. So I'd
But
say,
see, like your process in this particular one, like when we do the paralysis part, so it is like, as you see, like there are number of the gases released, and it is a high temperature process. Okay, the temperature is approximately more than, like, you have 800 degrees Celsius. Yes, 800 or 900 degrees. Yes.
I can't hear it. Sorry, can you repeat?
The temperature for paralysis is how much for your process?
We did 550 degrees.
Yes. So if you see this much temperature, if you are using the such amount of heat input is yes, very big amount of heat input is required. So
Yes.
economically, it is like the process is not that much, you can say, valuable. Research point, it is okay, but economically it is not valuable process, because
On
it
the
is
contrary, because when you mix in the improvements that we did, that about improving it using wind and solar, plus reusing the biogas produced, this will
yes, dear,
approximately
but
cut
see,
down.
like if you use a solar, how much temperature you can harness from this one? Again, you need a
It's an
technology.
electric furnace.
Yes, you need yes, but how much temperature that panel will give? That panel will not give you 500 degrees Celsius one.
That's
That
why I
panel.
said we're not just incorporating one thing; we're incorporating three mixed
No,
things.
but you said, like, that's why I'm said to you, like, that panel means, like, it require again a cost. So it's like the cost, the economical value is like
Okay,
very.
okay. For example, we're not using electric panels or anything like that. The biogas produced from the pyrolysis process is enough to produce the heat from that. process. And not only that, it's not a must use an electric furnace. Electric furnaces are actually quite costly.
So how
Like
much amount of that biogas is produced from this one?
How much amount of what?
Biogas, you said like it is sufficient for this, yes?
Approximately 36%
Okay.
from every kilo, you can say.
Okay, thank you.
Excuse me?
Thank you for the.
Okay, thank you very much. Should I send this PowerPoint to your email or something?
Thanks for this one. Okay, no problem. We have already your paper. Okay, thank you.
Thank you very much.
Yes, hello, good evening. Can you hear me? Okay. Can you see my screen? Oh. May I start? Okay. Hello, everyone. Welcome to you in my presentation to show what we did in a final year project, which is about flow velocity simulation of diffuser augmented wind turbine. Me, Salam Al-Haddadi, with my team, Athman Al-Maymani, Ayyub Al-Blushi, Marwan Jassasi, and our supervisor, Dr. Saad Al-Jabri. This presentation will contain introduction. We'll give you introduction about wind energy, wind in Oman, and then we went to literature review, methodology, and conclusion. I will start with the introduction. Wind in Oman. In the future, wind likely to play important role in Oman because Oman has the geographical possibility in that, as shown in the map on the right side. If you can see here, the red colors show the high wind power, and Dhofar and Ashaqiya has the most places which has the high wind power. On the left side, this graph shows that some places which have the high wind speed and Kurun Halti, Msaira, and Thamrit has the high wind speed. Actually, this is average wind speed for a long time. It's about 1 year. Then we'll go to development of wind turbine. Wind energy is one of the renewable energy that have been and are still used to serve humanity in agriculture, grain milling, water pumping, and generate electricity. And this graph show the development of wind energy and how much the people can generate in 1 year from 2001 until 2020. And we can see the difference from 2000, which is about 24 gigawatt, and in 2020, 792 gigawatt. And here we can see the high difference, and that's mean the people now interested more than past in the wind turbine and wind power, and also renewable energy. 3D printing. Actually, I will talk about this point because we used in our project. At first, 3D printing is a method for manufacturing where the material layers are fused together and pattern for creating the object layer by layer. And we used the FDM type. It's type we used in our project. Actually, we can use many types of material to print the object like PETG, ABS, BLA, and I will show you which material we used in our project to print the fan. Principle of principle and augmented diffuser wind turbine. Here I will show you how the diffuser actually work. When the wind enter the diffuser, it go out with lower speed because because the pressure at the end is low, and the pressure when enter is high. So there are difference in the pressure. It enter with high speed, and it come out with low speed, and that's high speed happen because the vortex when come out, it like it distribute the air, so there are low pressure at the end of the diffuser. We can say it's like a drag the air. Proper statement: there are two ways to improve wind turbine efficiency. One of them is increase swept area of turbine, and actually they try to ignore this one. And the second one is shroud with diffuser, which we used in our project. And objective. First objective is to design and fabricate and test different configuration of shroud wind turbine, and using the 3D printing to print the fan. Now we'll go to literature view. Its limit. Actually, in 1990, in 1990, a German scientist born called Betz. He bought he puts sorry he puts a rule for one turbine. Actually, this rule curve on the left side, all the single wind turbine without diffuser, without double router under this curve. There are two main type of wind turbine: horizontal axis wind turbine and vertical axis wind turbine. The difference between them is the rotating, the direction of rotating blades or the shaft. In horizontal axis wind turbine, the shaft rotate horizontally, and the vertical one, it rotates vertically. For horizontal wind turbine, there are many specific types like diffuser wind turbine, double router, Archimedes, downwind, upwind turbine. And for vertical one, there are Darius, Geometry, Savinius, and also we can use the diffuser for vertical one. Now I'll go to methodology. We did target specification. We used QFD, quality function deployment. It's a structure used to define customer requirements and translate them to specific plan. And if we can see here, there are high relationship between the cost and easy to maintain, easy to fabricate, and tough and strong material, and it has higher relative weight by 30%. Concept generation. We designed 5 concepts, and we choose one of them by using concept screening and scoring. Here is the concept A, which is has lens. Actually, it's a modern way. It started in Japan, called lens diffuser. Second one is multi-salted diffuser. The aim of that is to decrease the length of the shroud. Third one is simple diffuser. And third one is vorticity-based diffuser. Actually, they are not used so much this type. And the last one, which we use it and choose it after doing concept screening and scoring, shroud, which has diffuser and nozzle, and there are a brim for the diffuser. Now we'll go to a main point in our project. How we got the best dimension for our shroud. At the first, we made a nozzle, diffuser, and we make brim for them, and we enter this in SolidWorks. After design it in SolidWorks, we put it in box, and we apply some simulation on it by put wind speed 5 meter per second. Because it's average wind speed in Sohar, and we put the atmospherical pressure, and we try to change the geometry of the shroud, angle of nozzle, angle of diffuser, and length of brim, and we got this result. On the right side, we find the the length of the brim is a main factor to increase the wind speed. In the bottom curve, we put brim length 50 mm, and then we put it 100 mm, and we put it 150 mm, and we see here the difference in wind speed. Here is this relationship between ratio. It's ratio wind speed, and we reach about 2.6 when we designed for 150 mm. And on the other side, this is the dimension of our shroud, the diffuser with 10-degree angle, nozzle with 50-degree angle, and the brim with 50 degree and with 150 mm. Then we went to wind calculation. We calculate force max, F max, which they are equal 25.98 and 3.84. We calculated with speed 5 meter per second, because, as I said, it's the average speed in Sohar. And for F max, we calculated after we find it in SolidWorks. And we find also power max and power minimum, which they are equal 337.76 watt, and for the minimum one 19.2 watt. Fan fabrication. To fabricate the fan, actually, after we got the dimension of the diffuser, and we located the fan location, we choose the diameter of the fan, and as I showed you before, the diameter of where the turbine located are it has diameter 400 mm, so we design it less than 400, and the router has radius 192 mm. And we use NACA 4415 standard because it's a common standard used for wind turbine because the efficiency. And this video show some fabrication to print the fan. And as you can see, here is the SolidWorks design and the actual design. On the left side is actual design after fabrication, and on the right side is from SolidWorks. Project design. These are the separate parts of our project. Number one, base with the rectangular shape, 1 meter and 200 centi into 1 meter, and 4 wheels. Also diffuser brim, as I said before, 100 FM, and shroud holder with 150 diameter. The shroud and fan, as I said before, the radius of it is 192. Generator, battery, charge controller, and inverter. This we needed to electric circuit, and the shaft with diameter 20 mm. And as you can see here on the left side, this is the separate parts from SolidWorks. Financial model. Actually, we need about total cost 888 real to fabricate this project. We print the fan about 73.5 real, and we buy a blower to test it in the lab about 45, and the generator took 140 real, charge controller 28 real, step up power model post is 1.5 real, and the battery 500, and then fabrication 550 real. And if you can see here from the percentage, the fabrication took about 62% of the total cost, and it's more than half. Now we go to result and discussion. We use an anemometer to measure the velocity or wind speed, and we got this result. We did it about three times, and we took the average because the accuracy is not good. There are some difference between the values in every time. So we took average after 3 times, and we got velocity ratio about 1 point. The maximum ratio is 1.82. As I showed you before, the solid workflow simulation, the curves is in the top, and if in the bottom is experimentally result after we use an anemometer to measure the wind speed, and there are about 30% error. One of the mistakes actually, there are some mistakes in fabrication, and also this shroud should be tested in twin tunnel, because the SolidWorks simulation used like that. Now, conclusion. I talk about wind turbine, and I show you some type of wind turbine, and I talk about wind in Oman. Then I went to flow simulation and SolidWorks, and I talk about also 3D final design using SolidWorks. Then we went to fabrication and testing, and this is the final fabrication on the right picture. Acknowledgement. We want to thank my team with my supervisor, Dr. Sa'al Jabri. Thank Research Council Ministry of Higher Education, Research and Invention for supporting this project. If you need more information, this is our reference.
Okay, thank you for this one. I have questions for like you have used this particular experimental part also, you did it, and you did the simulation also, yes?
Yes.
Both the things you did it. So where is the variation you have shown?
Where? This one? Oh, wait.
Comparison. Where is the comparison?
This one.
No, you have done it like, for example, you did it some simulation part. Yes, yes, experimental is this one. So the gap is very high, yes?
Yes, as I said, because actually at first we use an anemometer, and we used a normal fan, and SolidWorks used like measure the wind speed like a wind tunnel. Actually, we don't have wind tunnel to test it, and we see actual result. If we use a wind tunnel, actually the error percentage will decrease.
What about like see in SolidWorks, like for example, like this, you did it this simulation, yes?
Yes, we did a simulation.
Just go further back to the simulation.
This one?
It's like where you have put it the model for the this. Yes,
Yes.
this one. This nozzle, this particular one. So this is developed by you, or like you have used this another one? This is.
No, we designed this by
This
ourselves.
one, okay. Okay. So can you just give me the details of this one? Tell me the details.
For simulation or for the shroud?
For shroud, all the things.
Okay. We designed, actually, we bring one of the experiment, one of the engineering from America, and we try to change the geometry, and actually he didn't put the brim like this, and we change the angle of the brim.
Yes.
Then we change the diameter with the turbine location, and we until we got the best dimension, until we see the velocity ratio.
Okay, so this is like you are you working in a SolidWorks?
Yes.
Okay, so you have which version of SolidWorks?
Sorry? What's CFD?
Computational fluid dynamics.
Actually, we use the 2021 the version of the SolidWorks.
Okay.
Yes. Sorry, complete. Yes, yes, we can this. There are we add boundary condition on it before run the program. We put the pressure atmospheric pressure. We use the viscosity for air, and we put also the wind speed from us.
Okay, what about your experimental part? Go to your experiment. Experimental this, for example, like not to go to the where you have presented the turbines, other things. Just go next one, next slide. Here, yes.
This one?
So yes, this one. So like you like, for example, in this particular one, you use different fans also for this one.
No, only one fan.
Only one
Only
fan.
one
What
fan,
was it?
yes.
What was the dimension for the fan?
The dimension here.
Okay. It is very small. It is 200 mm looking for me.
Yeah, yes, because where the turbine location, actually it's only for 400 the diameter of that.
So it's yes, that's why, because it is 200, so it is short. Yes.
Yes.
Where you did the experiment? All these things.
The experiment here in college.
College, okay.
Yes.
Okay, thank you, thank you, thank you for a nice presentation.
Thank you. Any question? Yes, thank you. Welcome. Thank you.